Alrighty. Hopefully this will work. This is Trig Lecture 914 and 915. I'm redoing it because I made a mistake the first time I did it. Hopefully I won't make the same mistake. The student will use trig function definitions to find the length of an indicated side of a right triangle. The instructions will be something along the lines of find the length of the indicated side, round to the nearest tenth. And I look at this triangle here. The indicated side is the side that's marked with a variable. It doesn't have to be an x. In this case it is, but this one's marked with a variable, so that's the side I'm looking for. I'm given the length of this side and I'm given the measure of this angle. So what I can do is, from the perspective of this 30-degree angle, ask myself what trig function would involve this side and this side. Well, a little bit of analysis yields this is the opposite side from this angle, and this is the hypotenuse. And the trig function that involves the opposite and the hypotenuse is the sine function. So I'm going to say, well, the sine of 30 degrees is equal to 14 over x. All right. Now I want to solve this for x. I'm going to show you a little bit of algebra, and then I'll show you a shortcut trick that you can use that will keep you from having to do the algebra all the time. In algebra, if we have a variable in the denominator in an equation, what we do is we multiply both sides of the equation by the variable. And you can think of this as over 1 if you want to. If you do think of it that way, you can see that these would cancel real easily, which is what we want. We don't want the x in the denominator. And the x shows up over here when I multiply both sides by x, so I wind up with x sine 30 degrees is equal to 14 is all that's left on this side. And then I say, well, I'm trying to get x by itself, so I'm going to divide both sides by sine 30. And here's my answer, 14 divided by the sine of 30. I've just got to get that into my calculator accurately, which I'll try to do. Last time what I did, the mistake I made was I said 14 times sine 30, and I didn't catch it until I rewatched the lecture, so I'm having to film it over again. So hopefully I won't do the same thing again. We got 14 divided by the sine of 30, so we get a calculator. Turn it on and clear it. 14 divided by the sine of 30. Click. That's 28. And that would be the length of the missing side. If this is 14, this is 28. Alrighty, that's what we're looking for. Now I want to show you the shortcut that we can use. It's a little algebraic shortcut. I'll move this over here. You can do it this way every time, but there's a little bit of a shortcut. If I said x sine 30 is equal to 14 over x opposite over hypotenuse. In a situation like this, if you want to, oops, I'm sorry, I made another mistake. If I said the sine of 30 is 14 over x, what I would say is I don't want the variable in the denominator, just like I said over here, and so I multiply both sides by x, then I divided both sides by 30, and notice what happened. This x and this sine 30 just switched positions. I get this disappears, and I get x equals 14 over sine 30. And look at it like this. It's just a little shortcut. X is all that's left over here equals 14 divided by sine 30. So if you look at how it originally looked, sine 30 equals 14 over x, x equals 14 over sine 30, you just switch these two. It's quicker than going through all of this. So I can say, switch these two, 14 over sine 30, which is what we got when we went through this. And then we just go 14 divided by sine 30, and I'll do it again just to make sure I haven't goofed it up. Yeah, 28. Very good. So this is the length of the side we're looking for. it says round it to the nearest tenth. We didn't have to round it to the nearest tenth because it turned out to be exact. Okay? So I would look for that among my choices. Here's one. Again, I'm looking at this, I'm asking myself, what trig function from a perspective of this angle would involve this side, which is the adjacent, and this side, which is the hypotenuse? So this is the indicated side because it gives me a side with a variable that's indicating to me this is the side that we want you to find. So I'm going to say, well, the sine function wouldn't work. It involves this side and the hypotenuse. Cosine, however, would be adjacent over hypotenuse, so that's the trig function I'm going to use. The cosine of 41 degrees is equal to x over 5, adjacent over hypotenuse. Now in this case, I don't have a variable in the denominator, so I don't have to multiply both sides by x or do the little switching around. All I got to do is get rid of a divided by 5. Up here, the little problem we had to do some algebra with is I had, the sign was 14 over x, my variable was in the denominator, and I got it out by multiplying both sides by x, and then dividing both sides by sine 30, and when I did that, it took my original equation and it just switched the place of these two. That algebra will just allow me to do that. Okay. So I don't have to do that here because the unknown is not in the denominator. So I'm just going to multiply by 5 to get x by itself. And I got 5 cosine 41, and I'm going to round it to the nearest tenth. Cosine 41 equals, and we've got x, this will be x over here. Oops. Is approximately equal to, because these cancel, in this case 5 cosine 41, enter that again, 5 cosine 41 degrees equals about 3.8. And that would be light years or miles or centimeters, but since it's not indicated what our unit of measure is, we don't have to indicate it in our answer. So in this case, I would just say x is approximately 3.8 units. Okay? And I would look for that choice among my multiple choice. Let's take a look at this one. I've got a right triangle. This is my indicated side. So I'm going to say, well, again, if I went opposite over hypotenuse, that's not the side that's indicated. How about adjacent over hypotenuse? I can do that. It involves a side that I'm looking for and a side that I know. So again, I'm using cosine. Cosine of 19.3 degrees is equal to adjacent over hypotenuse, which is x over 16. And here I have my x in the top again, so I'm just going to multiply both sides by 16. I'm dividing x divided by 16, and I undo that, so to speak, by multiplying by 16. And these cancel, and I multiply this side by 16 just to stay in balance. And then I've got x is equal to whatever this turns into. And that will give me 16 times the cosine of 19.3. And that's about 15.1 if I haven't made any mistakes. And that's an approximation, which is what that little dot means there. So I would say x is about, here's another way of saying approximately, 15.1 units. I don't know what the unit of measure is because they didn't tell me. If they'd said centimeters, I'd have to say centimeter. But they didn't say centimeter, so I'm just going to not indicate the unit of measure. But the length of that is about 15.1. If this is 19.3 and this is 16, this would be about 15.1. Okay? Units. All right, and here's one more example. I will try not to mess up. I'm looking for this side right here. I'm going to say I know this angle. I could say if I tried sine, it would be opposite over hypotenuse, so that would give me two unknowns. I don't want that. If I tried cosine, that would be adjacent over hypotenuse. I don't want that because that gives me two sides that I don't know the length of. So I'm going to try the tangent, and the tangent of 27 gives me 3 over x. So I'm going to try that. The tangent of 27, this isn't the only way you can do it, but it's as good a way as any. 3 over x, excuse me. I could multiply both sides by x and that would cancel out, and then divide by 27. And effectively, all that would do is change the position of those two. It would give me x is equal to 3 over tangent 27. It's just a little shortcut in our algebra. And then I just evaluate this with my calculator and try not to mess it up. And x will be approximately equal to whatever that is. So that'll be 3 divided by the tangent of 27 equal to about 5.9 if I haven't made a mistake. I'll look for that among my choices, and I found the indicated side. If this is 3, this is about 5.9 if that's 27 degrees, and providing I haven't made a mistake. So let me check real quick, make sure that on my calculator, I'll set it down. Tangent 27, so 3 divided by tan 27 equals 5.9-ish, and we chose to round it to the nearest tenth because that's what our instructions said. Okay? As indicated, student will use trig functions to find the length of the indicated side of a right triangle, which is what we just did, round it to the nearest tenth. In this case, it was an exact value, so we didn't have to round. We rounded that to the nearest tenth, and nearest tenth. Hopefully that made sense, and hopefully I haven't made any mistakes. Best of luck.